We're recording. 2-1, absolute value equations and inequalities. Why do we have two cases of when solving absolute values? So before we actually even start this, I have a question for you. Absolute value must be what coming out? Positive. It cannot be negative. So if I had something like this, you don't need to write this down, just pay attention. If I had the absolute value of 3x equals 9, what are my two possible answers? 3 and negative 3. So negative 3 times 3 is negative 9. The absolute value of negative 9 is actually positive 9. So what we have to do is have two cases, one for when the x is positive, one for when it's negative. So that I just answered the essential question for you. So, all right, let's go on to our notes. All right, step 1. Step 1, isolate the absolute value. Do you need to spell out absolute value? They're your notes. If you want to abbreviate it, that's fine. If you want to use the absolute, if you want to write a little v like an absolute value graph, that would be fine too. Isolate the absolute value on one side of the equation. So isolate the absolute value on one side of the equation. Step 2. Write the two cases. And what I mean by that is one must be positive, one must be negative. So write the two cases. Fine. All right, next, step 3. Solve the equations. Solve the equations. Check your solutions. Unfortunately, you must check your solutions because you'll have answers that are not correct, even though it's an answer, it's not correct. Answers can be one solution, two solutions, or no solutions. Does anyone know what it's called when you get an answer but it's not correct? No. No, we call it extraneous. And what's the root word of extraneous? Extra. Extraneous. An answer that is not valid. So therefore, Katie's answer was extraneous. Because it was an answer, but it wasn't valid. All right, Kyla's answer was strings. I just knew it came from that direction, and I knew it wasn't tie. All right, what's an empty set, Ty? All right, you do know. No valid answers. Because what we do is we do our little set, our little brackets, and there's nothing in it, so it's empty. It's an empty set. We can also use the circle with a line through it. That means the same thing. Annalise, keep the noise down back there, please. And I want to hear some lame excuse like it's thunder and not you. All right, I'm going to turn the page. Can I go on? Yes.
Does it matter which way, like, the arrow is going? Sometimes.
What's what? No valid answers. All right, ladies and gentlemen, we are now into the actual example part of it. All right, you got it? You're welcome, Jackson. Example 1. All right, time for big boy, big girl math. Not really, but we'll just pretend. Don't be scared, it won't hurt you. All right, first of all, step 1, isolate the absolute value. That is our absolute value right there, correct?
Yeah.
What does isolate mean?
Get by itself?
Get by itself, I like that. So we have a 2 to get rid of and a negative 9 to get rid of. What should we get by? What should we move first? Does it matter?
No.
I would get rid of the minus 9 because it's easier. Work smarter, not harder. So how do I get rid of a minus 9? So let's add 9, please, to both sides of our equation. So now we have 2 times the absolute value, 5x plus 1, equals 4x. 17 plus 9 is 26. All right, the 2 is multiplying, so to get rid of it, we divide. So now we have the absolute value of 5x plus 1 equals, what does the 2 go to? The 4x, the 26, or both? I like both. 4x divided by 2 is 2x, and 26 divided by 2 is... All right, our next step said write the 2 cases. So we have to have one positive and one negative. Is this one positive? So that means we need to write another one, but it has to be negative. So 5x plus 1 equals negative times 2x plus 13. All right, let's solve this side first. We're going to pretend this is not here.
Do we have to put the absolute value on the second one?
Do you want to? You don't have to. Because once we write it twice, it's going away. All right, which is smaller? I like to combine my like terms, and my like terms are the x's. Which is smaller, 2x or 5x?
2x.
So I'm going to subtract 2x because that'll keep our answer positive. 5x minus 2x is 3x. 3x plus 1 equals 13, because that's all that was left on the right-hand side. And now it's a two-step equation, which if you don't know how to solve this, I will write you a pass to go to guidance and get switched into liberal arts math, because that's what they do in there. So it's positive, so to make it disappear, we make it negative, or it's adding, to make it go away, we subtract. I like that better. 13 minus 1, I believe, is 12. Divide by 3, divide by 3, x equals 4. All right, let's try to go on to the other side. What property do I need to do to make this negative sign disappear? It is a multiply, but it's a special name. Begins with D. Distributive property. Very good. So now I have 5x plus 1 equals negative times 2x is negative 2x. Negative times 13 is negative 13. Which is smaller, negative 2x or positive 5x? So I'm going to add 2x to both sides. And 7x plus 1 equals negative 13. And this is called a two-step equation because it takes 2 steps to solve. It's a plus 1, so I'm going to subtract 1. 1 minus 1 is 0. 7x equals, if I borrow $13 and then borrow one more, I've borrowed 14. The 7's multiplying, so I do the opposite operation, which is division. Negative 14 divided by 7 is negative 2. What was our next step? Our next step was check your solutions. This is such an important step with absolute values. You must check your answers. So wherever I have an x up here, I'm going to replace it with 4 and solve. And then we'll do the same thing, but with negative 2. All right, so 2 times the absolute value, 5 times x, x plus 4, plus 1, minus 9, equals 4 times x, x is 4, plus 17. So x is 4. So wherever I had an x, I replaced it with 4. All right, let's do some not so advanced math. 5 times 4 is 20. 20 plus 1 is 2 times 21. 42 minus 9 is 33. 4 times 4 is 16 plus 17 is 33. So that answer checked. That's a valid answer. So we know that one of our answers must be 4. Does negative 2 have to work? No. We need to plug it in to make sure it does. So we're going to do the same exact thing. Plug in wherever we had an x with negative 2. Yep. 2 times the absolute value, 5 times x, x is negative 2, plus 1, so once again, wherever I had an x, which was right here and right here, I replaced it with negative 2. So I did not know you could erase highlighters. So I saw a student with these. How cool is that? You can erase that. I got them. It's mostly gone. It's just there a little bit. Who said it's still there? Jonah, was that you?
No.
Oh, was it Annalise or Jonna?
That was Annalise.
Because Annalise isn't about to be here. I'm just kidding.
Yeah, go ahead.
All right, moving on. Let's do some more not so advanced math. 5 times negative 2, negative 10 plus 1. So this is 2 times the absolute value of negative 9. minus 9 equals 4 times negative 2 is negative 8 plus 17. What's the absolute value of negative 9? So 2 times 9 is 18 minus 9. Okay, I believe that. Negative 8 plus 17. Does 9 equal 9? Yes, so we have two answers for this one, 4 and negative 2. Yes. But you're only going to have 8 problems, I think, for homework, and you're going to have all day tomorrow to work on it in class. But we need to make it through this first. All right, this is a check. What does a check mean? That you try it, and then you compare it with your neighbors, and then we'll go over it. All right, so please try that one on your own. Then Annalise is going to come on the board and do it for everyone. We'll see about that. Well, if you actually tell me the answer, I won't have you. All right, I'm going to take attendance now. Hopefully, I can do this with everyone moved. Well, I knew it came from the back table, so. All right, Valentina's here. Abby is here. Colin's here. Noah is here. Sakona. No, Sakona. Thank you. Jackson's here. Ty's here. Kate's here. Kyla's here. Gabby is here. Isabella's here. Cam's here, Dominic's, Annalise is here, Allison's here, Justin's here, Anna's here, Audrey's here, Yabdil's here. Liam is here. Liam, you got the problem done, I assume? That's why you're on your phone? You might have help at the board, Annalise.
Yes.
Johnny, are you in here? Nope. No. Landon? Nope. Elise is here. I knew that. Dahlia's here. Jonah's here. Joe. Thank you. Did you get it? Yeah. Okay. Okay. All right, there's 3 absent teachers today. Does anyone know who they are? Miss Britt, Mr. Wortman, and Mr. Santino. I heard one correct answer. All right, one more minute. All right, I'm going to go over this one now on the board. All right, step one, I believe, is isolate the absolute value. So I'm going to get rid of this x right here first. Plus x plus x. 2 times the absolute value of x plus 1 equals 4x minus 4. Divide by 2, divide by 2. The absolute value of x plus 1 equals 2x minus 2. All right, next step is I have to write as my two cases. So x plus 1 equals negative 2x minus 2. I wrote that wrong. I just said I wrote it wrong. You are correct. I should have done that. Hold on. I didn't mean to write that 2 there. That was a boo-boo. There we go. All right, let's go ahead and solve now. I would move the 1x to the other side. So minus x, 1 equals x minus 2, plus 2, 3 equals x, which I heard someone say they got 3, so good job, that is correct. But we need to check and make sure it works, so we're not there yet. All right, I need to distribute the negative. So that becomes negative 2x. Negative times a negative is a positive. Move the smaller variable. I believe negative 2x is smaller than 1x. (3x plus 1 equals 2). Minus 1 minus 1. 3x equals 1. Divide by 3, divide by 3. Oh no, we got a fraction.
Wait, so we don't use the original equation, we use the one that we made?
Yes. Wait, what are you talking about?
For the second one.
For the second one, we have to make, because we have to have one positive and one negative.
Yeah.
So we made this one negative.
That's what I did, but I used the original equation to do.
It's just easier to do this because your step one is isolate the inequality, right? So we're just working smarter, not harder. It's not wrong if you do that. It's just, this is easier. All right, so now we need to plug in and make sure it works. 2 times the absolute value of 3 plus 1 minus 3 equals 3 times 3 minus 4. 3 plus 1 is 4. 4 times 2 is 8. 8 minus 3 is 5. So we got 5 on the left. Let's see what we get on the right. 3 times 3 is 9. 9 minus 4 is 5. So that one worked. So 3 is one of our answers. All right, let's go to this side. It's a fraction. It must be difficult. Let's see if we can make sense of it. 2 times the absolute value of 1/3 plus 1 minus 1/3 equals 3 times 1/3 minus 4. What is 1/3 plus 1? 1 and 1/3. We have to do 3 times 1/3. 3 times 1/3 is 3 over 3. 3 over 3 is 1. Equals 1 minus 4. All right, we need to multiply 2 times 1 1/3. I personally would turn it into an improper fraction. 3 times 1 is 3. 3 plus 1 is 4/3. So we're going to multiply over here. 2 over 1 times 4/3. And that's going to give me 8/3. Is 8/3 positive? Yes, it is. And 1 minus 4 is negative 3. What is 8/3 minus 1/3? 7/3. Is 7/3 the same as negative 3? No. So that is a, do you remember what type of answer that is?
It's like extra something.
Extraneous. Good job. So we only have one answer for this problem, and that only answer is 3. All right, example 3.
Oh, wait.
Oh, should this be example 2? Okay, let's do that. Example 2. I think what I did is the check was actually example 2. So let's make this one example 2. I'm good with that. Example 2. All right, what's step 1? Get what by itself? No. Absolute value. We need to isolate the absolute value. So I'm going to subtract 10, subtract 10. The absolute value of 4x minus 7 equals negative 8. Allison, we have an issue besides my phone dinging. Is there any way an absolute value can be negative? So what do you notice here? It says the absolute value wants to be negative 8. Is that even possible? No. Thank you, Allison. That's cool how you threw your voice and made it like stereo. So your answer for this is an empty set. So you can either do the bat wings with nothing in it, or you can do the 0 with the line through it. But that's it. That's all. Honestly, you're going to see that again, and you're probably going to get it wrong because if I'm not paying attention, I make that mistake. You must ingrain in your brain anything, absolute value must be positive. You will see that question again in your future.
Can you go back to the...
I can do that. We have 2 more examples left today, and then we're done. All right, did you get it? All right, example 3, please. Absolute value 4x minus 8 minus 5 is less than 11. Uh-oh, we've done inequalities. And we're going to graph this too. It's okay. You'll live. It's not that difficult. All right, so what was step 1? Step 1 doesn't change. Isolate the absolute value. How do I get rid of a minus 5? Add 5. So now we have the absolute value of 4x minus 8. Oops, 11 plus 5 is 16. Is less than 16. So step 2 was write the 2 cases. For my first case, our 16 is positive, so it's going to turn into a, do I have to do anything with the sign? The less than is going to become a greater than. You are correct. Good job. So this is going to be 4x minus 8 is greater than negative 16. All right, so next step was solve. This is a 2-step inequality. I hope you can do that. add 8, add 8. 4x is less than 24. Divide by 4, divide by 4, x is less than 6. So now we're going to solve the right side. It's a two-step inequality, so it's a minus 8, so I'm going to add 8. 4x is greater than negative 8. Divide by 4, divide by 4, x is greater than negative 2. Remember, if you multiply or divide by a negative, what do you have to do to the sign? Flip it. We didn't on this one. I just wanted to remind you of that. So now we're going to graph this. So please draw a number line.
Can you say that again when we flip it?
Yep. If let's say I had 8 divided by negative 4 is less than x, we would be. Oh, hold on. Let me fix that. Hold that thought. Hold on. All right, there we go. Let's say we had 8 is less than negative 4x. How would I get rid of the negative 4? It's multiplying, so I would divide. So I'm dividing by a negative, dividing by a negative. So this would be negative 2, but you would switch the sign from less than to greater than. That's what.
So if it's negative,
If you multiply or divide by a negative, you flip the sign. All right, so let's go back to graphing this. I'm going to start at negative 4, negative 2, 0, 2, 4, 6, 8. What's my smallest number on there? Well, I misspoke. Which answer is smaller, negative 2 or 6? So I'm going to go to negative 2. I circle it. Do I shade it in? No, because there's not a line under it. And then I know it's going to go, see how the variable's in front of the number? I can pretend this is an arrow. And what way is my arrow going? To the right. So I'm going to start it going to the right. Now I'm going to go to 6. I circle it. There's not a line under it, so I don't shade it in. And what direction is this one going? To the left. So these are going to connect. This is called an AND. Do you know what it's called if they both go out? OR. So let's try example 4. And what do you think example 4 is? An OR, I think. All right, last problem for today. The absolute value, 6x plus 3 divided by 2 plus 5 is greater than or equal to 14. Step 1 is isolate the absolute value. How do I get rid of a plus 5? I like that option. So now we have the absolute value of 6x plus 3 divided by 2 is greater than or equal to 14 minus 5 is 9. So now we have to solve for x. What's the 2 doing to the 6x plus 3? It's dividing, so to get rid of it, so we're going to multiply both sides by 2. And those are going to cancel out. So now I have 6x plus 3 is greater than or equal to 18. All right, let's keep going. Minus 3, minus 3. 6x is greater than or equal to 15. Divide by 6, divide by 6. The 6's cancel out. And what goes into 15 and 6? Is there a number? Try again. 3. 3 goes into 15 5 times. 3 goes into 6 2 times. And as a mixed number, that would be 2 and a half. So we know one answer is x is greater than or equal to 2 and a half. All right, where did we isolate the variable, the absolute value at? Right here, correct? Because we got rid of the 2 and it left us our absolute value. So now what we do is go over here and do 6x plus 3. What happens to my sign? It switches, and what happens to my 18? It becomes negative. All right, that shouldn't be 18. I was just looking at it saying that shouldn't be 18. What should it be? Sorry about that. I had a brain cramp. We did it right here. So this is where we isolated our absolute value right here. So that shouldn't have been 18. It should have been negative 9. I apologize for that. So now how do I get rid of the 2? The 2 is dividing, so I multiply. So 6x plus 3 is less than or equal to negative 18. Minus 3 minus 3. 6x is less than or equal to negative 21. Divide by 6, divide by 6. Is there a number that goes into 21 and 6?
3.
So negative 7 halves, which is the same as negative 3 and a half. So let's go ahead and graph this. Negative 4, negative 2, 0, 2, and 4. So I'm going to go to 2 and a half. I'm going to circle it. Now there's a line under it, so that tells me I have to shade it in. And then we're going to the right. For the other one, x is less than or equal to negative 3 halves. Go to negative 3 halves, circle it, shade it in, and it's going to the left. So this one was not touching, it's going in opposite ways, almost like a boat with oars in the water. So this is an oar. And on that note, we have about 15 seconds till the bell rings.